According to the National Electrical Code, sump pumps that exceed 1/3 horsepower must be hardwired and also have a snap switch disconnect. This requirement is in place to ensure proper protection, effective grounding for the pump, and to prevent potential electrical fires or shocks. The manufacturer's warranty may become void if the plug is cut off from the pump and the pump is hardwired. This is because hardwiring the pump can alter the electrical characteristics and potentially void the safety certifications provided by the manufacturer. There are two possible solutions to resolve this issue. Firstly, contact the manufacturer. Discuss the National Electrical Code requirements with the pump manufacturer and inquire whether they offer a 3/4 horsepower pump model that already meets these requirements. If they do have a National Electrical Code compliant pump available, purchase and install that specific model. Secondly, install a ground fault circuit interrupter subpanel. You can install a subpanel with a dedicated ground fault circuit interrupter breaker. Hardwire the sump pump directly to this newly installed subpanel. This installation method should provide the necessary electrical protection and allow the use of the 3/4 horsepower pump without violating the National Electrical Code requirements. It is crucial to always consult with a qualified and licensed electrician to ensure that the installation fully complies with all applicable electrical codes and safety requirements. Do not ever attempt to modify or bypass any of the existing safety features of the pump or its wiring. These safety features are in place to protect from electrical hazards. It's very important to understand the National Electrical Code requirements for sump pump installations, particularly when dealing with pumps that are greater than 1/3 horsepower. The National Electrical Code, or NEC, provides guidelines to ensure safe and reliable electrical installations. For sump pumps, the NEC addresses wiring methods, overcurrent protection, and grounding to minimize the risk of electrical shock and fire. When a sump pump is rated over 1/3 horsepower, the NEC typically mandates that it be hardwired rather than plugged into a standard receptacle. Hardwiring involves directly connecting the pump's electrical conductors to a junction box or circuit breaker, providing a more secure and permanent connection. The reason for this requirement is to prevent the pump from being easily disconnected, which could lead to flooding in critical situations. Additionally, hardwiring reduces the risk of the pump being connected to an inadequate or overloaded circuit. Furthermore, the NEC often requires a disconnect switch to be installed within sight of the sump pump. This switch allows for easy shutoff of power to the pump during maintenance or in the event of a malfunction. The disconnect switch should be readily accessible and clearly labeled. Grounding is another essential aspect of some pump installations covered by the NEC. Proper grounding ensures that any fault current is safely diverted back to the electrical panel, reducing the risk of electric shock. The NEC specifies grounding requirements for the pump, the metal parts of the system, and the electrical conduit. It's important to use appropriately sized grounding conductors and connectors to comply with the code. Overcurrent protection is also crucial for sump pumps. The NEC requires that the pump circuit be protected by a circuit breaker or fuse of the appropriate size. This overcurrent protection device is designed to trip and interrupt the circuit if the pump draws excessive current due to a motor overload or short circuit. This prevents damage to the pump and reduces the risk of fire. When installing a sump pump, it's important to consider the specific requirements of the NEC in the local jurisdiction. Electrical codes can vary depending on the location, so it's always best to consult with a qualified electrician who is familiar with the local codes. The electrician can ensure that the installation meets all applicable requirements and is safe and reliable. In some cases, there may be alternative wiring methods or equipment that can be used to comply with the NEC. For example, a ground fault circuit interrupter, or GFCI, protected circuit may be permitted in certain situations. A GFCI is a device that detects ground faults and quickly interrupts the circuit to prevent electric shock. However, it's important to verify with the local electrical inspector whether a GFCI protected circuit is an acceptable alternative to hardwiring in a particular application. Another consideration is the manufacturer's instructions for the sump pump. The manufacturer's instructions provide specific guidelines for installation, wiring, and maintenance of the pump. It's important to follow these instructions carefully to ensure proper operation and to avoid voiding the warranty. In some cases, the manufacturer may specify additional requirements beyond those outlined in the NEC. It's always best to err on the side of caution and comply with both the NEC and the manufacturer's instructions. Failure to comply with electrical codes and manufacturer's instructions can have serious consequences. It can lead to electrical shock, fire, property damage, and even death. It can also void the warranty on the sump pump and potentially result in liability in the event of an accident. Therefore, it's essential to take the installation of a sump pump seriously and to ensure that it is done safely and in compliance with all applicable requirements. The National Electrical Code provides tables to determine the proper wire sizes for electrical circuits. These tables, such as NEC Table 310.15b16, take into account the ampacity of the wire, which is the maximum amount of current it can safely carry. The ampacity is affected by factors such as the wire's material, insulation type, and the ambient temperature. When selecting the appropriate wire size for a sump pump circuit, it is crucial to consider the pump's full load amperage, or FLA. The FLA is the amount of current the pump draws when operating at its rated voltage and horsepower. The FLA can be found in the pump's nameplate or in the manufacturer's specifications. Once the FLA is known, the appropriate wire size can be determined using the NEC tables. It's important to select a wire size that has an ampacity equal to or greater than the pump's FLA. Using a wire that is too small can result in overheating, voltage drop, and potentially a fire hazard. In addition to the FLA, it's also important to consider any applicable deterring factors. Deterring factors are adjustments to the wire's ampacity that are required in certain situations, such as when the wire is installed in a conduit with other wires or when the ambient temperature is high. The NEC provides guidelines for applying deterring factors to ensure that the wire does not overheat. Voltage drop is another important consideration when selecting the wire size for a sump pump circuit. Voltage drop is the reduction in voltage that occurs as electricity travels through the wire. Excessive voltage drop can cause the pump to operate inefficiently and can even damage the motor. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To minimize voltage drop, it's important to select a wire size that is large enough for the length of the circuit. The longer the circuit, the larger the wire size required to maintain acceptable voltage drop. In some cases, it may be necessary to use a larger wire size than is required for ampacity to meet the voltage drop requirements. The type of wiring method used can also affect the wire size requirements. For example, when using conduit, the NEC specifies the maximum number of wires that can be installed in a given size of conduit. It's important to comply with these requirements to prevent overheating and to ensure that the wires can be easily pulled through the conduit. When selecting wiring devices such as receptacles and switches for some pump circuit, it's important to choose devices that are rated for the appropriate voltage and amperage. The devices should also be listed by a recognized testing laboratory such as Underwriters Laboratories or UL. UL listing indicates that the device has been tested and meets certain safety standards. For sump pumps installed in damp or wet locations, it's important to use wiring devices that are rated for wet locations. These devices are designed to prevent moisture from entering the electrical connections and causing corrosion or electrical shock. In addition to the wire size and wiring devices, it's also important to consider the type of overcurrent protection device used to protect the sump pump circuit. The NEC allows for the use of either circuit breakers or fuses for overcurrent protection. Circuit breakers are automatic switches that trip and interrupt the circuit when an overcurrent occurs. Fuses are one-time devices that melt and break the circuit when an overcurrent occurs. When selecting an overcurrent protection device for a sump pump circuit, it's important to choose a device that is rated for the appropriate amperage. The amperage rating of the overcurrent protection device should be equal to or slightly larger than the pump's FLA. However, it should not exceed the ampacity of the wires in the circuit. The NEC provides guidelines for selecting the appropriate size of overcurrent protection device for different types of loads. Ground fault circuit interrupters, or GFCIs, are an important safety device for sump pump circuits. A GFCI is a device that detects ground faults and quickly interrupts the circuit to prevent electric shock. Ground faults can occur when electricity leaks from a circuit to ground, such as when a person comes into contact with a live wire. GFCIs are designed to trip and interrupt the circuit within milliseconds of detecting a ground fault, which can prevent serious injury or death. The NEC requires GFCIs to be installed in certain locations where there is a high risk of electric shock, such as in bathrooms, kitchens, and outdoor areas. While GFCIs are not always required for some pump circuits, they are highly recommended, especially for pumps installed in damp or wet locations. In addition to GFCIs, surge protection devices, or SPDs, can also be used to protect some pump circuits from voltage surges. Voltage surges are sudden increases in voltage that can damage electrical equipment. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. SPD are designed to divert voltage surges away from the equipment and protect it from damage. SPD are typically installed at the electrical panel or at the equipment itself. While SPD are not always required for some pump circuits, they can provide an additional layer of protection against voltage surges. When installing a sump pump, it's important to follow all applicable electrical codes and manufacturer's instructions. It's also important to use qualified and licensed electricians to perform the installation. Electrical work can be dangerous, and it's important to have the work done by someone who is trained and experienced. A qualified electrician can ensure that the installation is done safely and in compliance with all applicable requirements. In addition to the electrical requirements, there are also plumbing requirements for some pump installations. The plumbing requirements typically address the discharge piping, which carries the water away from the pump. The discharge piping should be made of appropriate materials such as PVC or ABS plastic and should be sized appropriately for the pump's flow rate. The discharge piping should also be installed with a check valve to prevent backflow of water into the sump pit. The check valve should be located as close to the pump as possible. The discharge piping should also be routed in a way that prevents freezing. Freezing can damage the piping and prevent the pump from operating properly. In cold climates, it may be necessary to insulate the discharge piping or to use a heat trace cable to prevent freezing. The sump pit itself should also be sized appropriately for the pump. The sump pit should be large enough to hold the water that accumulates between pump cycles. The sump pit should also be made of durable materials, such as concrete or plastic. The sump pit should be covered to prevent debris from entering and clogging the pump. The sump pit should also be vented to allow gases to escape. The vent should be routed to the outside of the building. When installing a sump pump, it's important to consider the local plumbing codes. Plumbing codes can vary depending on the location, so it's always best to consult with a qualified plumber who is familiar with the local codes. The plumber can ensure that the installation meets all applicable requirements and is safe and reliable. In addition to the electrical and plumbing requirements, there are also general safety precautions that should be followed when working with sump pumps. Always disconnect the power to the pump before performing any maintenance or repairs. Never work on a sump pump while standing in water. Wear rubber gloves and boots to protect against electrical shock. Inspect the pump and wiring regularly for any signs of damage. Replace any damaged parts immediately. Keep the sump pit clean and free of debris. Test the pump regularly to ensure that it is operating properly. By following these safety precautions, you can reduce the risk of accidents and ensure that your sump pump operates safely and reliably. In addition to the technical aspects of sump pump installation, it's also important to consider the environmental impact. Sump pumps can consume a significant amount of energy, especially if they are running frequently. To reduce energy consumption, it's important to select an energy-efficient pump. Look for pumps that are labeled with the Energy Star logo. Energy Star pumps are designed to use less energy than standard pumps. It's also important to properly size the pump for the application. A pump that is too large will cycle on and off frequently, which wastes energy. A pump that is too small may not be able to keep up with the water inflow, which can lead to flooding. To properly size the pump, it's important to consider the size of the sump pit, the average water inflow rate, and the desired discharge head. The discharge head is the vertical distance that the water must be pumped. In addition to energy consumption, sump pumps can also contribute to water pollution. Sump pumps discharge water into the storm sewer system, which can carry pollutants to local waterways. To reduce water pollution, it's important to properly maintain the sump pump and to prevent pollutants from entering the sump pit. Do not dispose of chemicals or other hazardous materials down the sump pit. If you have a spill, clean it up immediately. Inspect the sump pit regularly for any signs of leaks or contamination. By taking these steps, you can reduce the environmental impact of your sump pump and protect local waterways. It's crucial to be aware of the manufacturer's warranty terms and conditions for your sump pump. The warranty typically covers defects in materials and workmanship for a specified period. However, the warranty may be voided if the pump is not installed or maintained according to the manufacturer's instructions. For example, the warranty may be voided if the pump is hardwired when it was originally designed to be plugged into a receptacle. The warranty may also be voided if the pump is used for purposes other than what it was intended for. It's important to read the warranty carefully and to understand the terms and conditions. Keep a copy of the warranty in a safe place. If you have any questions about the warranty, contact the manufacturer. In addition to the manufacturer's warranty, you may also have coverage under your homeowner's insurance policy. Homeowners insurance typically covers damage caused by water leaks and flooding. However, the coverage may be limited, and there may be exclusions for certain types of damage. For example, homeowners insurance may not cover damage caused by flooding if you live in a flood zone. It's important to review your homeowner's insurance policy carefully and to understand the coverage and exclusions. If you have any questions about your homeowner's insurance, contact your insurance agent. Proper maintenance is essential for ensuring the longevity and reliable operation of a sump pump. Regular maintenance can prevent costly repairs and extend the life of the pump. The frequency of maintenance will depend on the pump's usage and the environmental conditions. However, as a general rule, sump pumps should be inspected and cleaned at least once a year. During the inspection, check the pump for any signs of damage or wear. Look for cracks, leaks, or corrosion. Check the wiring for any loose connections or damaged insulation. Check the discharge piping for any clogs or leaks. Clean the sump pit to remove any debris or sediment. Debris and sediment can clog the pump and reduce its efficiency. Remove any standing water from the sump pit. Standing water can promote the growth of bacteria and mold. Test the pump to ensure that it is operating properly. To test the pump, pour water into the sump pit until the pump turns on. Observe the pump to ensure that it is pumping water efficiently. Listen for any unusual noises. If the pump is not operating properly, consult a qualified electrician or plumber. In addition to the annual inspection, it's also important to perform routine maintenance as needed. For example, if you notice that the pump is cycling on and off frequently, it may be a sign that the sump pit is filling up with water too quickly. This could be due to a clogged drain or a high water table. If you notice any unusual noises coming from the pump, it may be a sign that the pump is damaged or worn. If you experience a power outage, check the sump pump to ensure that it is still operating properly. Power outages can damage electrical equipment, including sump pumps. By performing regular maintenance, you can keep your sump pump operating smoothly and prevent costly repairs. Ultimately, compliance with the National Electrical Code, understanding manufacturer specifications, and adhering to local plumbing codes are all essential components of a safe and effective sump pump installation.